Section 8.5 is on angles of elevation and depression. The angle of elevation is the angle formed by a horizontal line and the observer's line of sight looking up. So here's a diagram. We have a person standing here on the ground. Okay, that person's horizontal line of sight is right here. So we need to think of that as like one side of the angle. And then this person is looking up at a bird in the tree. So that's their line of sight looking up. The angle of elevation is this angle right here labeled X. So it's formed by the horizontal line of sight and the line of sight looking up at something. That's why it's called elevation. Angle of depression is the angle formed by a horizontal line and the observer's line of sight looking down. So here we have somebody standing on top of a building or a tower, and he's looking straight out. That's his horizontal line of sight, but then he's going to look down at this flower on the ground. So the angle of depression is this angle that's formed here by his horizontal line of sight and his line of sight looking down at the flower. So let's take a look at a couple examples here. And the hardest part of any of these problems is drawing the picture, because basically what we have to draw is a right triangle. So, at the circus, a person in the audience at ground level watches the high wire routine. A 5-foot 6-inch tall acrobat is standing on a platform that is 25 feet off the ground. How far is the audience member from the base of the platform if the angle of elevation from the audience member's line of sight to the acrobat's head is 27 degrees? Okay, so let's draw a picture here. So, here's the ground, and here's the person standing there. Well, let's say he's kind of sitting in the audience. Okay, here's the tower that the acrobat is on top of, and your drawings don't need to be really exact or to scale, but they do need to kind of represent what's really going on. Here's the acrobat, and the acrobat is 5 feet 6 inches tall. So that's actually 5.5 feet. Okay? And we know that this platform, this tower here, is 25 feet tall. Okay? And we know that the angle of elevation, so this angle, actually, you know what? I'm going to draw this person. Hold on. I'm going to draw this person actually kind of like sitting at ground level. So let's imagine he's in a chair and he's like right here. Okay, there we go. So this angle right here that's formed by his line of sight looking up at the top of the acrobat's head and the ground, this angle right here is 27 degrees. Okay, so do you see the right triangle? So the line of sight looking up, the height of the acrobat and the platform she's standing on, and this distance here. And actually, that's the distance I need to find. It says, how far is the audience member from the base of the platform? So this distance here is what I'm going to call X. So I have a triangle. Here's my hypotenuse. Here's one leg. Here's the other leg. And I know that this is a 27-degree angle. So I'm going to use my trig functions that we learned in the last section. So my angle is 27, so I'm going to do sine, cosine, or tangent of 27, but I need to use the information I'm given. This distance right here, which is a total of 30.5 feet, the height of the acrobat plus the height of the tower, that's my opposite. I'll go ahead and label that. My opposite is 30.5. And the length I need to find here, the distance right here, that's going to be my adjacent. So the trig function that uses opposite and adjacent is tangent. So I need to do the tangent of 27 equals opposite, which is 30.5, over x, which is what I need to find. So solving this, remember we did this in the last section, I'm going to multiply both sides by x and then divide both sides by tangent of 27. So x is equal to 30.5 over the tangent of 27 plugging that into my calculator. Does it tell me how I'm supposed to round? It doesn't. X is approximately 60 feet. So the audience member is approximately 60 feet from the base of the platform. Here's another example. Maria is at the top of a cliff and sees a seal in the water. If the cliff is 40 feet above the water and the angle of depression is 52 degrees, what is the horizontal distance from the seal to the cliff to the nearest foot? So let's draw a picture here. So here's the cliff that Maria is standing on, and here's the water. Don't have to be an artist, okay? Let's see. Maria's up here, and she is looking down here at a seal in the water. And I'm not going to try to draw a seal. We're just going to write seal. There's my seal. And she is looking down at it. Now, a common mistake that people made is they're going to want to call this angle right here the angle of depression. But that is not the angle of depression. Remember, the angle of depression is formed by the horizontal line of sight, which in this case would be something like that, okay, and the line of sight looking down at the seal. So this angle right here is actually my angle of depression, and the problem told me that that was 52 degrees. Some other measures that we have, we know that the cliff is 40 feet above the water, so that's 40 feet, okay, and we need to find how far, let's see, what is the horizontal distance from the seal to the base of the cliff. So basically this right here. Now, isn't this distance here, the pink line that I drew across the bottom, actually going to be the same as this right here? So I'll draw this down to the seal. Oops. So the length of the pink line on the bottom is the same as the length of the dashed line that represents her horizontal line of sight. So that's what I have to find right there. And actually, maybe let me put that one in pink so it kind of stands out a little bit. So I know that that's, whoops, 40, that's x feet, that's what I have to find. And this line over here is also going to be 40 feet. Because basically what we've drawn is a large rectangle with a diagonal. So I'm going to focus on this triangle over here, and I can draw a right angle there. I'm going to focus on this dashed triangle over here. My angle of depression is 52. I need to find this horizontal distance, and I know that my vertical distance is 40. Well, in relation to 52, 40 is adjacent. I'm sorry, 40 is opposite. And x is adjacent. And the trig function that uses opposite and adjacent is tangent. So I'm going to say the tangent of 52 is equal to opposite, which is 40, over adjacent, which is x. Solving that for x equals 40 over the tangent of 52, or x is approximately equal to 31 feet. So the seal is approximately 31 feet from the base.